this does not hold your substatement. So to prove that an existential statement is wrong, you have to use the variable as variable. You cannot take a particular value of the variable and prove that it is wrong. That will not settle the case. However, for a universal, okay, now let us look at the situation for a universal statement. We already have one. This is a universal statement and this is false. We already know it. How to prove that it is false? You need just one value of x for which this is not true. For example, you can take x equal to 3. For that 3 plus 1 is equal to 4, which is not equal to 2. So since the statement says that this substatement is true for all real x, only one case where it fails proves that this is not the case. It is not true for all real x. We don't bother about any other value of x for which it is true or not, since for all is involved. That is not happening. It's not true for all real x. One example is enough to show that this is false. So the statement, universal statement, is false. And this type of examples which show that a universal statement is false is called a counter example. So to show that a universal statement is false is rather easy, just like showing that an existential statement is true. However, to show that a universal statement is true is as easy or as difficult as showing that an existential statement is false. Okay, for example, we can take that statement itself, modify it. X square is non-negative for all real x. This is again a universal statement, but not like this one. This is true. In this case, one example is not enough. You say 1 square is equal to 1. So essentially we are just doing that same thing that we did before, but now we are showing that this is true because our substatement is different. Previously it was x square less than 0. Now it's x square greater than or equal to 0. You have taken x equal to 1. Fine. You can take x equal to pi. Okay. You can take x equal to minus 1. Pi square is equal to pi square. So this is greater than 0. Minus 1 whole square is equal to 1, again greater than 0. None of these is enough to prove this. In this case, you have to treat x as such, as a variable, and show using properties of real numbers that square is always non-negative. It cannot be negative. Okay, so these are things associated to existential and universal statements and their proofs or disproofs. Okay, non-proofs. Keep these things in mind. If you don't understand this part, you will get confused because in mathematics, variables are everywhere. Oh, and speaking of variables, I should also mention that although we have so far used statements involving only numbers, variables can be vectors also, functions also, matrices also. Okay, and in some cases they may even be other mathematical structures like groups, rings, but since those things are coming at this elementary stage, I don't want to say about them. For example, you can yeah, look at this. You are almost surely familiar with this Newton's second law of motion for an object of mass m, where the mass is not changing. F is the force acting on that object and A is the acceleration of that object. Here F and A are vectors, and you can see that they are variables. I am not writing some specific value of the vector. Okay, so this is a statement involving a vector variable. So you have to here mention that these are vectors. Okay, F is the force vector, A is the acceleration vector. So like that you may come across statements which involve matrices and other mathematical objects. But keep in mind, every time you write a statement involving variable, you have to mention the type of the variable. Otherwise, it would not make sense. Okay, that has to be kept in mind. Now, having said these things about when, what quantifiers are and what variables, how variables are to be dealt with when quantifiers are for all or for